we are going to see the topic of implementations of single linked list using this program. In this program, it shows how the node is to be inserted, how the node is to be deleted, how the node is to be displayed and modified, also free the node in the allocation memory, and also the single linked list and also the double linked list. Only the inserting and deleting node is shows in the double linked list. Finally, difference between the array single linked list and double linked list shows in this PPT. First slide, implementations of single linked list by the program. In this case, first one is type def. No, this is all the type def. In this first one, if def and if not def is declared in this program. It is here if def is and if not def in the single linked list of program. Next one is type def. Using the type def, declaring the code shortly. For example, a single linked list /s. This is using the structure of type def, and it shows the SLL_T. It is shortened by the SLL_T only by the type def. This is the one outcome of the program, outlook of the program in the section, and this is the main function. This is main function, void main. It contains the choices. In case I put the choice 1, choice 1 means insert node, choice 2 means delete mode, choice 3 means add modify and display, and also the default print the invalid choices. So I want to put the choices first, then only the node is performing based upon the choices only. If I case put the choice 1 means first one is inserting mode in the singly linked list. It allocate the memory in the dynamic way. So single linked list and double linked list both are memory is dynamically allocated. So first of all, we're going to call the function to inserting node. In this include header file, the current directory searches in the header file, because available in the structures is in the current directory only. And the next one, g has to be null and g tail to be null. In the first one, we containing the node of 2. This 2 is the starting g head and g tail, and this 2 is also the temp. In inserting node, this is clearly said, this is allocating memory and printing the data, entering the data. If I enter the data of 3, okay, this is 3 and this is 4, this is 3. Okay, I want to inserting the node of 3. So I using first, this is only I alone, this I have. In this 2, using the head, tail, also the temp. Temp next means this one is allocated null. After inserting the node means this pointer is going to be the 3. So this is inserting the node means this node is also inserting, and this is going to be null, and this is temp and this is temp next, and this is going to be, this pointer is going to be 4. In keep on similar way to inserting these nodes by this program. In such, head is equal to null means head is equal to temp, tail is also equal to temp. In the first one, this is first one is 2. We check, I enter the data is 3 only. Check 2 is equal to null. No, it is not equal to null, so going to the else part. G tail is equal to next, and next equal to temp. This next is going to be the temp. G tail next is going to be temp, and this temp to be the G tail means next one is created, and this is to be the G tail. This way to inserting node by this program. And after this else part, it going to the starting and entering the data as 3. It checks here 3 is equal to null means it entering the code, this is null point, and also you inserting the 4. This null is going, this is the header temp, and tail is also the temp. This is else part, it going to be the G tail to next. This is G it is G tail, and this is G tail's next, and the G tail next is the temp, means G tail is next to the temp. This is the new temp variable, and this is the 4. This way to keep on inserting the node easily. And in the function index equal to hash temp data is the hashing table to be indexed. Index means it directly giving the number. 5 means it directly given the number, but in the single linked list, traversing from the first one to inserting the node, it is difficult to inserting and deleting the node in single linked list. Next one is deleting. If I case put the cases to be 2, means it deleting the node. First I know which node is to be deleted. Next one is from the header pointer I traverse the node to be deleted, put while loop, because I know how many node are in the linked list, got head pointer and assigning to be the temp. In this way, this is the value, it getting the temp of G head and previous also pointer. Previous and temp pointer is there. Entering the data to be deleted first I should do, and next data is to be getted from the user, and this is the code to previous equal to temp, and this is the loop is true, means if check temp is going to be data. Temp is going to data is equal to data. I given the data is 3, means we check the 3 is equal to data. Then the node is to be deleted. Temp is equal to head. Checking the data, it to be deleting the command previous equal to next and temp to next to delete the selected node. This is the command. It is not given, it is given in this previous equal to next and equal to temp equal to next to delete the selected node. If I selected the 3, keep on looping this process. When I got the 3 and this previous node, in single linked list, this is the previous and this is the next. Previous, this node is to be in case is this first node is 2, and this is 3, and this one is 4, means this 2 is pointing to the this 4. From 1 this is head and this is temp, and the next one of searching 3 means this is head and this is temp next, and the temp is going to move on this point. So this is actually the temp next. The matching of 3 is gated, and going to the 2 is to be 4, and this 3 is to be deleted. This 2 is pointing to 3, this is pointing to this 4. So this 3 is deleted and allocate the memory to be free. Okay, this way of node to be deleted. And the next one is modify the node. And the one of the main thing is when memory is allocated, it placed in the heap for the dynamic memory only. Once I use this memory, I can this functions free. Operating systems know the memory is free, so this memory is allocated for another purpose. Whatever you memory using malloc, I need to be free. It otherwise it calls the memory leak. Memory leak is the major bug in the software. If forgot to free it, it keep on hanging it, not used for the other purpose, as not allocated anybody else. Okay, so we allocated the memory in inserting or deleting or whatever purpose, it's to be free at last. We not needed at the time. Okay, next one is modify. Free and display both are in this slide. First I going to see the modify. When the node is to be modified, if I editing the node or wrongly I typing the node points to the 3 to 4, that time we modify the node. In case we have the 3 node, first one is 2 and second one is 3 and third one is 5, we want to modify the third node to the fourth node in this functions only, use in this functions only. From the program, this is the modified. Fix the head positions entered to be data and to be changed using the loop to looping the data when 3 is to be matched by the this code. First entering data is to be 3 and 3 is changed to be 4. No, this is we want. First entering data is to be 3 and checking the data, keep on looping the checking data. 3 is equal to 3 and then break command is there. After getting 3 it will be break and temp is equal to temp to next. The data in such, this is the 3 nodes. No, 3 nodes. This is null pointer and this is 2 and this is 3 and this is 5. We want to change this 3 into be 4. We reach the 3, then temp, this is temp, this is temp, this is head and this is tail, and in this case we check the command 3 is equal to 3, this is temp, this is next to temp. This point is going to points 3, this point is going to points the 5. Then temp is equal to null is given in this position. That time the loop is to be changed whenever we get the 3 and automatically we put the data. Here it will put the data is 4, means 3 is to be modified to 4 and then temp to data. This temp to data is going to change the 4 and this not going to be 4 and this is going to be pointed 5, and the temp is equal to null wherever it reach it. This is null, it reaches the temp and the program is data not found is the to be printed. This is simple. And next one is the display node. How the node is to be displayed means fix the head position in node, print data in the list using the while loop. When insert node, I get the data and the name is to be displayed by the displayed mode. In first case I inserting the node, no, that time printing the data and names, these are all displayed by in this printf. Using this printf to getting the name and data only, the node is to be inserted, the values are to be inserted in the inserting mode. So we use in this display. This while value is true, print the values and going to the next. Temp is also changed to next node, then print the values and temp to the next node until the loop is to be false. While is reach the null loop and it is false, null means 0, no, so it is to be false, and print the blank lines and come out the loop. It is very easy. For example, this is these are the 3 loops. Print in this head, print the loops and going to the next, print the values and going to this. When the while is to be 0 and loop is to be get out from the loop. Next one is free list. What is the free list? Free list means we already said free means giving the memory is back. It used the free temp. Using this free temp memory is not for the program. Temp is equal to temp to next. Accessing this memory is illegal, so it might work or might not be work. It is wrong way of doing it. Before freeing using temporary variable, be free equal to free. This is be free equal to free. This is the temporary variable to using to move the pointer and to be free it. Fix the be free equal to temp, then it is free the first node, it going to be the next node to assign the temp, and free it to reach the null. It comes out the loop by the above program. It is working by it containing the 3 nodes. Okay, this is 2 and this is 3 and this is 4. I want to set the loop. This is the be free is equal to temp. Okay, this is to be temp equal to temp. This is temp and this is to be temp next. So this loop is to be totally free and moving to the next loop, and this is to be the be free equal to temp. So this is to be temp and this is to be temp next, and it going to the next node and it is to be free. And same thing is reached the null, while loop is false, it come out the loop. This is how the working of a modified displace and free list working. In double linked list is also inserting and deleting modus happens, but in the double linked list easy compared to the single linked list. From delete the node is get the pointer in one to another. It has the two pointers, no? Double linked list has the two pointers and single linked list has the one pointer. Need not to be traversing where I want to delete the previous node and next node. But in the single linked list I want to traverse from the head pointer then inserting then deleting. But in the double linked list I need not to be traversing. I get the for inserting, for I said the inserting means this is the next node and this is the previous node. This is to be the this Joshua is to be the Leon, and Miriam is to be the Leon, and this pointer, previous pointer to the Joshua, this next pointer is to the Miriam. This is simple way of inserting the node. Same deleting the node is from the double linked list. It has the double no. I want to delete means this is next, this is previous, this next is to be the this previous, and this previous is to be the this next. So this node is automatically deleted. This is easily deleting the node in the double linked list. And the final thing is difference between the array single linked list and also the double linked list. I mentioning these array performance is better because in I containing the arrays of 1000 list, find the array of 99 is get immediately by the index, but in the single linked list it is slow only, traverse from the head pointer. But on the double linked list it is fast, need not traverse from the head, it is also from the array only, going to get directly in between the arrays inserting or deleting operations is performs. But array is the very first to be get the nodes easily. And allocate memory is a continuous locations in array. These both are dynamically, and addressing is assigned by the data types only. It inserting and deleting is difficult and it is to be easy. This is same, and this is by the allocation memory is data type, not by the dynamic. Like int means 4 types, double means 8 types, and long double it also containing the various such cases, and float means also 4, and also pointer has the data type of 4 only. So using the pointer address structure is also used in the arrays, it containing the data type allocations only. Memory is allocated not in the dynamic range but is it in the dynamic range. In the difference between these, it not go backward from the head to the traverse. If example in single linked list we have the array of this one and this 2, this 3. I want to insert in this array, I want to delete this array. From the first one to I traversing and check this then only this I getting, but in the it's not going to backward, this is going to forward only. But in the extra pointer have the double linked list, no, it is going to backward and forward whenever I want to inserting and deleting the list is becomes so easily in the double linked list. So it has the extra pointer, so it has the extra memory, but it not has the extra pointer, it has only the one pointer, it occupies the one memory only. So these are all the types of the linked list and how it performs is by the programs. Thank you.